Hello, everyone. Welcome to the Bard Show. And let's go ahead and talk about the prerequisites for easy learning. I put this in here so people understand that it's helpful if you have a background in digital electronics, algorithms, which is coding, elementary electronics, preferably BJTs, FETs, diodes, some college algebra, so you might have to learn how to read a graph, circuits, and understand gates and gates. Got to understand that. An inductor. We're going to be talking about relays, diodes, voltages, circuits. Got to know how to connect it, grounding. There's some mathematical analysis, so it helps know Ohm's law and stuff like that, and maybe KVL, KCL, and all that good stuff. This right here, there's a flow chart. The flow charts are great for this this session. But I'm just saying this is what you should know. If you don't know, don't panic. We're going to conquer and divide. This is a very interesting. Well, it's an interesting studies. I believe it. I mean, this is my favorite. I love Embedded. It's a lot. It uses everything. It uses everything from coding to electronics, and it uses everything that I could think of. So we're going to divide and conquer, and we're going to take it slow to understand all the features. So let's talk about the next feature, which is the nuclear board 64 import. So this is the family of nuclear boards. There's an FRE 11, and then there's one minus like the 76 RG, all that. So let's go ahead and take a look at this. So 1.71 to 3.6 operating voltage. That's very important to know that, and that is for when you connect voltage to analog to digital ports. So the analog is the voltage, okay? You don't want to go beyond 3.6 volts when you're connecting into those ports. The ADC is the sensors. Also, this has a current maximum is 10 to 11 milliamps or so. So it's not going to be, if you're putting some voltage from the board and your external component doesn't work, let's say you don't have you have a sensor, or you have like a little LCD screen, and you put some voltage from the board itself and you realize it's not turning on, well, probably because there's not enough current. And so you got to keep that in mind. The processor speed is 80 megahertz. Believe it or not, that's pretty fast considering this is a RISC, the reduced instruction set. So they cut out a lot of stuff for graphics. In fact, you need a board. 512 static RAM. Now, that seems like a lot, but there is a pretty good size IDE that we use, a development that has that in the background. It uses quite a bit of memory, okay, because there's a lot of stuff. There's a lot of functions that are happening behind the scenes to make our lives a lot easier, okay? 2 digital to analog ports. So these are kind of important. I know a lot of the Mbeds don't have that. They use PWM instead. But for our case, it's good to have that for right now, just to know what that does. So that takes the digital output from the board, and it turns it into an analog, which means it could turn into like a sound, like speakers, and then you get some sort of like music or voice or something like that. That's supposed to be analog. 16 analog to digital. So that's coming for sensors. But remember, when you put a sensor, there has to be a voltage coming to it. All right, let's go to the next slide. This is the bird's eye view of the Nucleo 64 family. I wrote this because I use both the Nucleo 5411RE, but they're all the same. All the pinouts are the same. They're all exactly the same. So when you look at them, They're all going to look exactly the same. There, you see, there's a lot of ports. You'll see like there's a PB, um, like a PA1, PA6. That's for as we advance, get into sensors and into outputs and all that, and into communication devices. For right now, I don't get hung up on everything right now. All you need to worry about is the PC 0 to PC 15. That's the digital outputs. So that's the digital outputs for diodes, for motors and stuff like that. Those are the digital outputs. And there's ground, of course. And so just take a look at your device and kind of just get kind of comfortable with your device. This is the chip. So I put this in here. This is off of the operator's manual. And believe it or not, everything is connected. All these ports are connected to this chip. Now, there are some resistors in there. There's some pull-up 10K resistors that you can enable, and that's fine. And we'll show you that as we progress. But this is all coming off of this one chip only, and so I think it's amazing. So now we're going to talk about the main headers and all that. So let's talk about it. So the 5.5 volts, you'll see it as it's pointed. There's a 5 volts on the board that will produce 5 volts, and there's a 3.3 V3. That means that will produce 3.3 volts. There's the ground. The VIN is for batteries, 5 volts to 9 volts. That's for when you want to disconnect it from the computer. There is a USB up here, and what that does is that sends all the data back and forth to your laptop, preferably to your to your embedded device. Now, the analog out. Now, only the L476RG. Well, I don't want to say only, but so far the one I picked has analog out that converts the digital code to an analog waveform. Okay, so it could be speech, it could be music, it could be noise, it could be something that's analog, some kind of a varying of the voltage that comes out, or a waveform. You'll see there's the analog in, as we discussed before, are for sensors, for light sensors, for buttons, for you could put a keyboard to it, like a tiny keyboard, for ultrasonic sensors, LiDAR, I mean, whatever. But understand that it needs to be reduced from 1.1 volts to 3.6 volts. Don't have it any higher than that. The next we're going to talk about are the serial. There's the IC squared, the SP1, and all that. The IC, those are just communication devices. Those are output devices. Those are to communicate the data going back and forth. That could be coming back and forth to an LCD display. It could be any type of. It could be another Arduino. It could be a transmitter. It could be whatever. Okay, NC means non-contact. PWM is pulse width modulation. This is what they use instead of analog out. Many embeds don't use analog out because it's kind of like you have to add a analog to, or a digital, a digital to analog converters, and that could be kind of complex on people designing chips, or they just feel like it's just not very worth it because the pulse width modulation can do the same thing, and we're going to discuss that a bit later on. So this is the parts list. So instead of me going to each, oh shoot, I got to get a LED. Oh shoot. Rather, if you follow my channel and you're going to go through, we're going to be doing a series of all kinds of experiments. Not quite sure how many, but maybe about 10 or so in this block. And so you need 8 LEDs. Get multiple color LEDs. There is a 2 multiple color LEDs, a common cathode, a 7-segment display. Don't panic if you get a common anode. I know how to fix that. A silicon diode, just a 12-volt motor. That's just like a little DC motor. Don't get an AC motor. Just get a DC motor for toys and stuff. An optical light sensor transistor. Yeah, that's okay. And a normal open button. That's just a button that's normally open. So when you close it, it will contact the circuit and close the circuit. 1 BJT transistor. Make it NPN. I repeat, make it NPN. Don't make it PNP because that's going to make things. You have to put the positive instead of hooking it to the ground. You're hooking it to the positive end, and that's just going to make things all mucked up. Okay. Next we got parse list continue. This is get a relay. Get a 12-volt relay. Make sure it's 12 volts. Get 2 MOSFETs. Those are tiny MOSFET NPN channel. Enhanced MOSFET. You should see in the teleprompter. I repeat, enhanced MOSFETs. A small signal, by the way. 2 10K ohm resistors. Those are for the buttons. 390 ohm resistors. Those are for the diodes. That's optional, tell you the truth. I usually don't put those in, as I explained before. Spools of multiple wire, red, blue, green, yellow wire. Female connected wire. Now, what that means is you need it to hook to the terminal. So you can get those. You can get that on Amazon, but just make sure you can get that at I think there's a parts center. Just make sure it's female connected for pins. Okay. All right. And okay, so tools you need. These are tools you need. Definitely need a laptop computer. You can't do anything without a laptop computer or desktop. Preferably laptop because you can carry it around on your desk and it's just a little bit more portable. 1 variable power supply. I know that stinks. The reason why you may need that is your little Arduino, even though there's a lot of devices that require 5 volts, those little Arduinos or those little microcontrollers do not have enough power. As the voltage times current equals power, you may not have enough power to actually power up that device. So you do need a variable power supply. Make sure it has a current protection on there. Preferably 2-channel, 0 to 30 volts DC. Keep in mind that if you buy one that's keep in mind that has a lot of current, so it could, if you short it, it should have a current, so it will just basically turn off. It won't set on fire. Okay, the next thing is a 2-channel oscilloscope. You can use, I think it's Analog Discovery. You can use those. Those are pretty cheap. They got everything in there. I just use my own oscilloscope and power supply. In fact, you can use, sometimes it has its own power supply in that one, and it could be enough current, so that could be more bang for your buck. Look into that. That meant to say DMM. Okay. And 1 wire cutters. Okay. Yeah, I put variable power supply twice. I don't know. Okay. And thank you. Subscribe to more Embedded to come. Okay. There's more subscribe, more Embedded to come. If you like it, thumbs up. Put a comment down. If I'm going too fast, just let me know, and that would be. Or if I'm going too slow, it's like, oh man, let me know. Or just say hi, man. That's Your videos are awesome. Okay, thank you. Enjoy. Bye-bye.